Okay, so moving forward to our discussion on first order ordinary differential equations this afternoon, this will be our topic: linear ordinary differential equations and the Bernoulli equation. Now, linear ordinary differential equations are one of the most commonly occurring differential equations. No? So, halos mga DEs na ito ma-encounter in the future might be linear in fashion. So, this is of importance to us in our field in engineering. Yet, fortunately for us, this is also one of the most easiest to solve. Okay, uh, even if that would be higher order, linear ordinary differential equations, sayo na po na sila solve. Okay, so today we'll only be focusing with first order ordinary differential equations or first order linear ordinary differential equations. Now, how do we know if it's a linear ODE? Okay, so using algebra, by algebra, a first order ODE is said to be linear if it can be brought into the form y prime plus p of x times y is equal to r of x. So, kanina na akong iingon is nani sa slide. So, please refer to it. Pero if not, kaya pwede naman mo maminaw sa atong sa akong i-project na pen and paper. Okay? So, again, it's linear if it can be brought into this form, y prime plus a function solely of x, p of x, again, times y is equal to r of x. Okay? So if it can be brought to this form, it's a linear, or at least it's a first order linear ODE. Okay? And p of x and r of x are functions solely of x alone. Okay? Functions x alone. Okay? So there are two types of linear ODEs. We have a homogeneous linear ODE and a non-homogeneous linear ODE. So forget that definition that we have before of homogeneous ODEs. So dili ito mao. Okay, lahi na po din siya ang klase, but this is the more formal definition for homogeneous ODEs. If r of x, okay, if our function on the right-hand side of the equation, if r of x is equal to 0, so our linear equation is a homogeneous. Homogeneous linear ODE. Okay? Homogeneous linear ODE. But if not, or if r of x is not equal to 0, then it has a value or it has a function on the right-hand side of the equation, then it's a non-homogeneous. Non-homogeneous linear ODE. Okay? So, meaning we have two sets of solutions for any given linear ODE. First, we must determine if it's a homogeneous or not. So what if it's a non-homogeneous? What if r of x has a value? So lucky for us, or fortunately for us, again, linear ODEs are one of the easiest to solve. Okay, because of the solution is already predefined. Now, what do I mean? What do I mean when I say predefined? If it's a non-homogeneous again, the solution would look like this. Non-homogeneous the solution y of x would be equal to e to the power of negative h of x times the integral of e to the power of h of x times r of x dx. Okay? Plus c. Yan na. So, yan na lang. Okay? Um, actually, all of these are already given. R of x is given. Yeah, R of x is given, but where will we obtain h of x? No? H of x is equal to the integral of p of x dx. Okay, so that's it. No? So again, everything else is given. R of x is given from the equation. P of x is already also given from the equation. No? So it's just a matter of plugging in and operate. Okay. But what if it's a homogeneous linear ODE? Homogeneous linear ODE. Linear first order ODE. Okay. Meaning R of x is equal to 0. The solution is just as plain as this one. No? So all of this would be equal to 0, diba? Because R of x is 0. So all of this is equal to 0. So it's just the c times this one, no? Negative h of x. So y of x is just equal to c times e to the power of negative h of x. This one, no? And that one, because all of this is 0. Okay? Question so far? I think it's better to solve an example to have a clearer view of what linear ODEs are. No? So let's solve some examples then. Example number 1. Y prime minus 2 of xy is equal to x. Okay. So is this a linear ODE? Yes or no?
Yes, sir.
Yes, sir.
Yes. Okay, thank you. So unsa man ang atong p of x and what is also our r of x? So clearly our r of x is x, no? Our p of x is
Negative 2x.
Negative 2x.
okay, very good. So p of x is equal to negative, okay, 2x, because the original form is a positive 1, no? Or positive in sign. And r of x is not equal to 0 but equal to x, okay? So I hope that's clear. So we can conclude that this is a linear ODE or linear first order ODE because all of these are functions of x alone. Okay, negative 2x, x, no? So that's the first step, pointing out what is p of x and what is r of x. So because r of x is not 0, it's a non-homogeneous. Again, it's just a matter of using these two um, formulas. Okay. So first, let's determine our h of x. Okay. So dali lang ni siya, we just integrate p of x. Okay. So our h of x is equal to the integral of p of x dx. That's p of x, negative 2x. Okay. Formats at day, no? So this is our given um, required is course y of x and solution. First, determine h of x. So the integral of p of x is negative 2x. So the integral of negative 2x dx. Therefore, our h of x is just equal to negative x squared.
X squared.
Okay, x squared. Or negative x squared. Naman tayo negative. So negative x squared. Okay, very good. Okay, so we already have our h of x. Next, just invoke this formula. If you could memorize this one, the better. No? Y of x is equal to e to the power of negative h of x, the integral of e to the power of positive h of x, r of x dx plus c. Again, plug lang. Okay? Y of x is equal to e to the power of negative x squared. E to the power of negative x squared. The integral of e to the power of negative x squared. What is r of x? X. R of x is x dx plus c. Okay? And that's it. Finish na ang differential equation na part of our solution. So, it's integral calculus's turn to solve the DE. So let's focus on this one, this part. No? So what kind of integration technique will we use for this one? Hmm. It's obviously what? Substitution by parts?
Um,
U. Okay, very good. U substitution. So what's our U? U is negative x squared. Therefore, du is negative 2x dx. Therefore, dx is du over negative 2x. Yeah, that's correct. So just replace everything by u and du over negative 2x. So this becomes the integral of e to the power of u. Dx is du over negative 2x. Okay, so cancel out si x. So it's just eu du. So eu, negative 1/2. Negative 1/2 e to the u. Or negative 1/2 e negative x squared. Okay. So we replace this part by this one. So our y of x is equal to e to the power of x squared times this one, negative 1/2 e to the power of negative x squared plus c. And we're almost there. No? Multiply both expressions by e to the power of x squared. Negative 1/2 e to the power of negative x squared times e to the power of x squared plus c e to the power of x squared. So what will happen to this one? e to the power of negative x squared plus x squared. 0. So e to the power of
0,
0,
1.
1. Okay, very good. So the only thing that's left is our negative 1. I mean negative 1 half plus c e to the power of x squared. And this is our final answer. No? So it's pretty easy, right? Compared to our previous uh, types of ODEs. So don't forget the formula. Let's try to solve another one. Say you're given y prime plus y tangent x is equal to sine 2x. With initial condition y is equal to 1 when x is equal to 0. Okay? Linear? Yes or no?
Yes, sir.
Okay,
Yes,
so our p of x is tangent x, purely a function of x. Our r of x is sine 2 of x. Again, purely a function of x alone. And a non-homogeneous for that matter because it's not equal to 0. Okay, so p of x is tangent x. R of x is sine 2x. Okay, formula. H of x first. Okay, h of x is equal to the integral of p of x dx. Equal to the integral of tangent x dx. As integral of tangent x. If I'm not mistaken, ln of secant x.
Yes, sir.
Okay, very good. Thank you. So ln of secant x. Okay, mana. Invoke the formula y of x is equal to e to the power of negative x. E to the power of negative h of x multiplied by the integral of e to the power of h of x r of x dx plus c. E to the power of negative ln secant x. ln secant x integral of e negative positive ni dire power of ln secant x. What's r of x? Sine 2x. Sine 2x dx plus c. Okay. May mga walaan eh. This one.
second lang.
Second. This is sine 2x. Second na lang ni siya. Correct.
Yes, sir.
To the power of negative 1. So this becomes y to the power of x. Y of x is equal to Don't forget the negative 1 in front of ln, ha? So this is secant x. It's not arc secant, ha? It's secant x to the power of negative 1. Secant x to the power of negative 1. It's not arc sec. Okay. This one is only becomes integral of secant.
Second.
No? Secant x. Okay. Positive man siya. Times sine 2x dx plus c. Aha. Identity, right? What's the reciprocal of secant?
Cos.
Okay, very good. Cosine. Cosine x. The integral of secant x. If I'm not mistaken, sine 2x is 2 sine x cos x. No? 2 sine x cos x. Mm. Second, sine 2x is 2 sine x cos x. Sakto? Wala pa ito nag-integral, ah. So there's something na cancel here. Secant and cosecant are reciprocal of each other. So cancel those. It just becomes the integral of sine x. Ano? Dx. So that's the thing that's missing. No? Cosine x to integral of sine x dx plus c. Yeah. The integral of sine is negative cosine.
Yes, sir. Yes, sir.
Okay. So y of x is equal to cosine x negative 2 cosine x plus c. Right? And distribute cosine x. Y of x is equal to negative 2 cosine squared x plus c cosine of x. Final answer? Not yet, because we have initial conditions. Condition. Y is equal to 1 when x is equal to 0. Okay. Subject this to initial value condition. Y is equal to 1 at x is equal to 0. So y is 1 when x is equal to 0. Cosine 0, if I'm not mistaken, is 1.
1.
Okay. 1. So 1, negative 2 plus c. Therefore, c is equal to 3. 3. Final answer, just replace c by 3. Y of x is equal to negative 2 cosine squared x plus 3 cosine x. Final answer. Any questions? Are the steps clear and defined?
Sir.
Okay, I hope so. So far, I think that's easier, no? So how about the Bernoulli equation? Okay, so the Bernoulli equation is a um, special type of equation that could be reduced to a linear equation. No? So what does a Bernoulli equation look like? A Bernoulli equation looks like this. Okay? Y prime plus p of x times y is equal to g of x times y raised to some power a. And that's it. No? Now, um, when a is equal to 0 or 1, our given equation becomes linear. So try to imagine if this is 1, no? If y is 1, we could transpose this to the other side, combine the y's, and we have a homogeneous function. No? Still a linear homogeneous function. If a is 0, y to the power of 0 is 1, so mawala na eh. It becomes a purely non-homogeneous equation. So that's the first thing that you should look for if the power is either 0 or 1. So it's an automatic linear homogeneous or non-homogeneous equation. So if a is not 0 or 1, it's a Bernoulli equation. So what do we do to convert a pure Bernoulli equation into a linear one? No? So we use uh, another function. No? So na letter itong gamitin. U. Okay? So we'll use u of x. So we'll use u of x as stand-in. U of x is equal to um, y of x to the power of 1 minus a. Okay? And we replace um, all y's with this one. Same with y prime. Okay? Now we do not need to derive it today. We just use or invoke this formula. U prime plus 1 minus a p of x times u equal to 1 minus a times g of x. Okay? Where u are our dependent variable. And after replacing all these variables, we'll be surprised that the outcome of this one would be a linear ODE. The same process will be undergone. No? Okay. So start to practice. No? Given. Given y prime plus xy is equal to xy squared. Okay. So it's clear that this is a Bernoulli equation. Y prime, our p of x is x, our g of x is x, and our a is 2. Okay. P of x is x, g of x is x, and a is 2, meaning y is raised to the power of a. So use this one, u of x um, y to the power of 1 minus a. So 1 minus 2 is negative 1, meaning u of x is equal to 1 over y of x. Okay, so just remember this function or this relationship. Now, invoke this formula, u prime plus 1 minus a p of x times u, 1 minus a g of x. Okay. So u prime plus what is a again? 2. So 1 minus 2 is negative 1. So negative 1 p of x is x times u equal to, again, negative 1. And g of x is x. U prime minus x times u is equal to negative x. Now, doesn't that look like a linear ODE? This one.
Yes, sir.
Diba? Our p of x is negative x. Our r of x is negative x. The only thing different is our dependent variable is, instead of y, it's u. So, linear. Okay. Non-homogeneous. Where p of x is negative x and r of x is also negative x. Diba? Non-homogeneous. So, h of x. Okay, of course. H of x is the integral of p of x dx. Therefore, our h of x is negative x squared over 2. Then, formula, u of x is equal to, not y of x, because our dependent variable is u. So u of x is equal to e to the power of negative h of x. E to the power of positive h of x, r of x dx plus c. Okay. Just plug in everything. Diba? This becomes positive e to the positive x squared over 2. The integral of e negative x squared over 2 times what is r of x? Negative x dx. Okay, let's see. Again, this is u substitution. But let's not use u. Okay, nagamit naman si u. Let's use another letter na lang. No? Let's use z. Z substitution. So let z be equal to negative x squared over 2 dz is equal to negative 2x dx. Is this correct? Negative 2. Ano?
X, sir.
Yeah, extra. dz is equal to negative x dx. Or dx is equal to dz over negative x. Okay. Negative x. Therefore, this becomes u of x e to the power of positive x squared over 2 integral of eu du directly because negative x will be cancelled out. So e negative x squared over 2 derecho plus c. I think that's correct. So distribute this one. U of x is equal to, what's the product of this one? We have the same exponents but negative. Equal to 1, right?
1, sir.
So 1 plus c times e to the power of x squared over 2. Okay. Not yet final answer because this is still our u of x. Earlier, we substituted u of x is equal to 1 over y of x from this one. This one. So u of x is equal to 1 over y of x. So u of x is equal to 1 over y of x. 1 plus c e over 2. Therefore, or y of x is just equal to the reciprocal of this one, 1 over 1 plus c e x squared over 2. I believe this is the final answer. Questions? Senra? Last one, last example. Okay. Initial body condition. Bernoulli equation where A is 5. Okay. So it's a Bernoulli equation where A is equal to 5. Therefore, our U is equal to y of x 1 minus 5 Therefore, our u is -4. So 1 over y to the power of 4. Y of x na. Okay. So just use the formula. U prime plus 1 minus a times p times u is equal to 1 minus a times g u prime. U prime plus a is 5, so -4. U equal to -4. G is negative x to the power of 9. Right. Linear ODE. Where P, ano, napalita P of x dayo. 2 over x. -8 over x. Okay. This is -8. Where our P of x is equal to -8 over x. And our R of x is 4x to the power of 9. Purely functions of x alone. So because it's linear, solve for h of x. The integral of this one, P of x. No? Integral of -8 dx over x. -8 ln x. Is this correct? Y of x is equal to e power of negative h of x. So, positive na siya. A ln x, the integral of e -8 ln x times r of x times 4x to the power of 9 dx plus c. This becomes x to the power of 8. This one, x to the power of -8. X na lang ni. X squared over 2. 4 over 2 is 2. Yx is equal to x to the power of 8. X squared over 2. 4 over 2 is 2. 2x squared. Let's see. 2x to the power of 10 plus c x to the power of 8. I know this is not y, uni siya. Therefore, uni siya, u of x, 2x to the power of 10 plus ex to the power of 8. Just replace u with y. No, this one, y over x to the power of 4. I mean, u is equal to 1 over, yeah, y to the power of 4. So our final answer would look like this one. Dili pa, because namatay initial conditions. Reciprocal and then fourth root. Okay. This is the expression of our general solution. Now, initial value, y is 2 when x is negative 1. Y is 2, x is negative 1. So y is 2. What is our c? Negative 31 over 16. If I'm not mistaken, it's negative 31 over 16. Find c. Therefore, our final answer is equal to the fourth root of 1 over 2x to the power of 10 minus 31 over 16 of x to the power of 8. Final answer. So for all the formulas, please refer to the slide that I've uploaded on eLearn. So everything is there. Questions so far? Understand? Sabot ta guys. Okay, now what I want you to do for the next what I want you to do for the next minutes, next 30 minutes, is answer this one. Okay. As it work. And then under the activities and problem set module in our eLearn, there's a column there named sit work of this date. So you're going to post your answers this afternoon there, no, for everybody to see. Then later, 30 minutes from now, I'll try to see if someone got the correct answer. Okay? Sige. Let's see each other after 30 minutes.